For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below.
We're given a matrix A and a vector W, and they're asking us to determine if W, the vector, is inside the column space of A. The column space of A is just to span all of the linear combinations of these vectors and their respective scalars x1, x2, and x3. So we're really just asking, are there x1, x2, and x3 that will combine with your matrix A with these columns and give you W, so 2, 1, and negative 2. It's supposed to be a negative 2 there, by the way. So in other words, we're solving for AX is equal to W. So ideally, that means you take your matrix A and you put W in here and you want to know if there is a solution to this system. In other words, you can just do an augmented matrix A of W and you're trying to find if there's a solution to the system. If it's not, that means that there aren't any x1s, x2s, and x3s. There aren't any vectors as such that will multiply with this matrix to give you W. So all you have to do is put it into reduced row echelon form, and then you see 0 is equal to 0. What does that tell you? It tells you that there are many x1s, x2s, and x3s, many vectors like this that will multiply with your matrix A, with the columns of A, that will actually give you 2, 1, negative 2. That will give you W. And so therefore we can say that W is indeed in the column space of A. It is one of the vectors. So remember, column space is just the space of all of the vectors that you can get by combining any vector of this form with this matrix, so all of the possible B values. And so we're saying that yes, W, which is 2, 1, negative 2, is in this space, in the column space. So yes, the vector W is in the column space of A, and if we're being fancy, we say that W is an element of the column space of A. Then for B, they're asking us if W is in the null space of A. Well, then you would ask yourself, what is the null space of A? The null space of A is the space, or it's just the collection of all of the vectors that your matrix sends to 0. So if W is a vector in the null space of A, that means that the matrix A sent W to 0. So in other words, we're just solving for AX is equal to 0, or in this case, AW is equal to 0. We want to know if that's true. If A times W will give me 0. If it is, then W is for sure in the null space of A. So here we have our matrix A and our vector W. So this is basic matrix vector multiplication. So if you need a refresher on that, go ahead and watch the video in Sarai Studies, link in the description box below. It's under the linear algebra section, lesson matrix equation 1.4. So the first thing you do is make a big matrix, and then you take each column and you're going to copy it, but every time that you copy a number, you're going to put a parenthesis afterwards. So that would be negative 8, parenthesis, 6, parenthesis, 4, parenthesis, and then you're just going to separate each column by plus signs now. So in the second column would be negative 2, parenthesis, 4, parenthesis, 0, parenthesis, and then separate by plus signs, parenthesis, 8, parenthesis, 4, parenthesis. And then what numbers are going to go here? Well, visually what I think is I'd like to rotate this like so, and so this number is going to be the one multiplying all of these. This number is going to be the one multiplying all of these, and this one is going to be the one multiplying all of these. So in other words, on top of every single column, I'm just going to write the number in the order that I see it. So I see 2 first, so it's going to go up here, 1, and then negative 2. So 2, 1, and negative 2. So I'm going to drag 2 all the way down, I'm going to drag 1 all the way down, and I'm going to drag negative 2 all the way down, and then that's it. Now you just simplify. So this becomes negative 16, this becomes 12, this is 8, this is negative 2, this is 4, this is 0, this is 18, this is negative 16, this is negative 8. So 18 minus 16, that's 2, minus 2 is 0. So your first entry is 0. Then 16 minus 12, that's 4, negative over powers, so negative 4 plus 4 is 0. And then 8 minus 8 is just 0. And so look at what we have. We have the 0 vector. We multiplied W by A, and so A sent W to 0. So in other words, W, this vector here, is in the space of all of the other vectors that A sent to 0, to the null space of A. And so we can say that yes, W is in the null space of A, and to be specific, W is an element of the null space of A. And that's it for this video. I'll see you in the next.